All right, next concept, the idea of the components within an ecosystem. These components are critical in understanding what's happening. You have two, biotic and abiotic, and I hope that you would know the difference at this point from biology. Biotic is the, whoops, let's do something a little bit darker than the green. All right, let's go living, and abiotic is non-living. All right, we're going to talk about these two very, very soon, but let's look at non-living. This is what's really important. We kind of forget about this all the time, but if you look at the diagram below, there's a huge number of non-living factors. If you think about it, could you name a few? One being sunlight. The amount of sunlight, that's an abiotic. Amount of precipitation, abiotic. The amount of water, abiotic. The slope of the land, abiotic. It could be the type of soil, abiotic. These are all the non-living components. Okay? It's basically, you're talking about wind, or I should say air, water, and sunlight, meaning like temperature and things like that. Those are abiotic factors. And of course, the biotic components of an ecosystem are very easy. You know that, the living parts. Okay? So understand the different abiotic parts. And we'll move on, because the abiotic parts end up in these things called limiting factors. Okay? A limiting factor, if you want a definition, for those people who like to have definitions, a limiting factor would be some sort of, usually abiotic component of an ecosystem, okay, that limits the population growth. A limiting factor is exactly what it says. Oops. We will try to do this again. With, I think this chart would probably be even better to use than the other one. Okay, so let's do it this way. Limiting factor, I just forgot to write down what it was, is a factor that limits the growth of a population of a species. So it limits population growth. Let me explain exactly what I mean by that. Okay? So what you do is you pick an environmental factor, what we call a limiting factor. It could be, say, temperature, or it could be the amount of sunlight, or it could be the amount of water in the soil. Whatever that is, typically there is what we call an optimum range. All right, where the species will grow, their population will grow, everything will be great, and it usually falls within a certain range of that particular environmental factor. Okay, where the population does very well. So it could be a temperature range. If the temperature is either too warm, let's say, or too cold, okay, or it could be too much water, too little water, whatever, then you start seeing stress and the populations are decreasing. You won't see as many of those particular species. So it's under stress, we call it. So it's stress on both sides of the limiting factor. Either too low over here or too high. When you go beyond that, all right, they call it the zone of intolerance. I call it the limit of tolerance. Okay? And at that point, whatever this abiotic condition is, this particular limiting factor, if you go any more extreme than this particular species cannot survive. Okay? So you have the range of tolerance is this whole entire area where you could have species. They like this area the most, so it's called the optimum range. If you go outside the optimum range, over in here, okay, or here, we call that zones of stress, and then there's the limit at the end. Okay, so this is going to become very important, and there's great examples of how we as human beings change the limiting factor so that we push a limiting factor outside its zone of stress into the limit, and then the species goes extinct. All right, so it's a very, very important point to understand. right. Moving right along. Here's a great example of fish and their range of tolerance for different temperatures. And you'll see that in the case of fish, rainbow trout are the ones that need the coldest temperature, with their optimum range being right around here, sort of in this area. All right, that's what rainbow trout like. So they have to be in cold streams. So if you want to have trout in your streams, you must have the temperature being very cold. If your stream temperature has pollution, or there's some kind of pollution causing the stream temperature to go up, you're going to lose the rainbow trout because they have a limit. And you may end up with bass, largemouth bass. So these you find in lakes, because lake temperatures can usually get much warmer than river temperatures. All right, so just an example for us to look at. All right, and finally, the last part, the components of an ecosystem, based now on how they obtain their energy. Okay. And I think you've learned a little bit of this before. Autotrophs, all right, are organisms, all right, for those people who haven't had biology or forget their biology. All of you had biology. Autotrophs make their own food. If you want to look at it that way, real simply, autotrophs make their own food, and that's how they get their energy. And there's two ways that you can make your own food. One is the process of photosynthesis, okay, and two is the process called chemosynthesis. We're going to get into both these discussions in detail in a later PowerPoint. But photosynthesis, obviously you all know, is how plants use sunlight to make energy. In chemosynthesis, they don't use sunlight, but these particular organisms use some chemical, okay, or some mineral. In this case, this is very famous for at the bottom of the ocean, near ocean, what they call ocean vents, which you learned about a little bit in the Earth Science section. And these are volcanic vents that give off sulfur at the bottom of the ocean. And these particular organisms have developed a way to take sulfur and use it to produce energy. Just like photosynthesis has used the sun into the plants to produce energy, chemosynthesis, the greatest example, is using sulfur from volcanoes, volcanic vents. When you have these vents with the material coming out, there's a lot of sulfur, and you get these incredible biodiverse systems down there with lots and lots of life forms. We didn't even know these existed for the longest time until more recently we discovered them, and then we found out that these extremophiles, or these guys who process chemosynthesis, make up almost a third of all life on the planet. All right, we always thought it was photosynthesis which was all life, until we discovered chemosynthesis. Okay. Moving right along. Once you get through the autotrophs, then you have to go into the heterotrophs. Heterotrophs can't make their own energy. They have to consume it from something else and get their energy from something else. All right, and these you hopefully heard of before. Herbivores are organisms that eat plants and get their energy from the plants. Carnivores are meat eaters. They get their energy from eating prey. Omnivores eat both plants and animals. Bears are great omnivores, okay, where they eat both plants and animals. Decomposers, things like bacteria and fungus, the saprophytes, okay, they basically break down decomposed material. All right, those that you should all be familiar with. The one you might not be familiar with is a thing called a detritivore. What they do is they eat detritus. It's a word that I use a lot that everyone says wrong, but detritus. Okay, and what that is, detritus is dead plant or organic material. All right, this is dead plant or any type of organic material. All right. So what I'm saying here is that detritivores come before decomposers if you're talking about taking material and breaking it back down into soil. So these are the little pill bug guys. These, all right, earthworms. Okay, the centipedes and things like that are going to take large material that died, all right, and break it down. All right, and we like to call them detritivores. All right, into smaller molecules, which then can be broken down by our good old fungus and decomposers. All right, so these are heterotrophs, feeding relationship in which you fall into different categories here. Okay? And that will take us to the end of lecture number 1. Deep breath. Okay? Hopefully I didn't put you to sleep. So at this point, you should now know what an ecosystem is and how its components interact with each other. And this is the first step in the beginning of a long process to better understand how our natural world actually functions and how we humans impact it. You can't understand how we impact it unless you know how it functions. You now finished step 1. Thank you for listening, and we'll be talking once again in another series of ecosystem concepts.